Hello and welcome to another one of D's ADD videos. Today we're going to look at a concept video for U substitution. What is U substitution? Well, U substitution is your first ace up your sleeve. Basically what that means is if you can't do algebraic manipulation, you can't do a trig identity, you can't do them individually, then you try U sub. And in U sub you ask yourself this question here. Can I take the derivative of one part of the problem and get the other part? Okay. So do I care about coefficients? No. Do I care about the x's? Yes. I want the same number of x's to the same power. Alright, and I'll show you what I mean by that later. And when you're assigning U, don't worry about the square roots. Is it an exponent? Is it in the denominator? Is it a power of U? When we set U equal to something, we just set it equal to the basic expression only. Okay? So what are the steps? You assign U, the one that you can derive and get the other part of the problem. Derive both sides of your U expression. Solve for dx. Plug in what dx equals into your problem, and your U should be right there as well. So plug in dx and U. And then cancel all x's. Integrate in terms of U. Should be a much easier problem once you've substituted. And then plug back in what U equals and you should be done. Alright? So here are some example problems. I'm not going to do them now. I just want to show you what I mean by assigning U. Now there's no way I could let U equal this thing up here, take the derivative of x and get 1 over x squared plus 1, right? But if I let U equal x squared plus 1, ignoring the fact that it's in the denominator, ignoring the fact that it's raised to the third power, the du term becomes a 2x dx, which I have an x dx right there. Don't care about the coefficients. Alright, so yeah, that would be U sub problem. Let's look at this one. At first glance, that might not seem like U sub. There's no way I can take the derivative of x plus 2 and get all that, so I try x squared plus 4x, again ignoring the radical. If U equals that, then du would be 2x plus 4 dx, and we have one x term and a non-x term. Left in our problem we have one x term and a non-x term. So you should be able to see that if I factor out the 2, I get the x plus 2 I desire. So yes, this is also a U sub problem. Alright, and then you would divide both sides by all of this. I do it a little different than some of the professors. They just would have divided by the 2 and gotten a du over 2 and substituted x dx. I mean, that's fine if you want to do it that way. I prefer to physically watch my things cancel out when I'm doing these problems, and I'll show you why when we do some of these examples. The derivative of ln, if you ever see an ln and you see an x in the bottom, so ln and x in the denominator, that's a U sub problem, because the derivative is 1 over box d box. So U would be your ln x term, du would be 1 over x dx. Okay, and then here, if you have an e, if there's one e, you'll let U equal the exponent. And if you can derive it, in this case, the derivative of 3x cubed is an x squared term. So yes, that would work for U substitution. Okay? So practice these is the best way to become good at them. There's some sneaky U subs that I'll show you that you might not see coming if you don't know about them. But this is a pretty straightforward technique. So practice, practice, practice. Check out the example videos. Thank you and have a nice day.